Over the past few months, I've built a few RAG AI applications, one of them for a client, a few of them for myself just to learn more about the technology. This is one that I've built for myself, and it's based off of an archive of like interesting tweets that I screenshot. I put them in this application, it turns them into Markdown, and then it does RAG with them to kind of help me find interesting information. For example, what's your take on LLM frameworks? Is an interesting question I might ask it, and it's going to do a multi-step process of figuring out what my query is about and then finding interesting content that I have saved on that, and then produce an answer with the LLM on it. So you can kind of see the consensus among various sources that LLM frameworks, particularly LangChain, may add unnecessary complexity, blah, blah, blah. That's not the point here. The point here is to kind of explain what even is RAG, right? Well, you have to first understand the problem that it solves. You have an LLM, the LLM is smart, it's amazing, it's fast, right? Think ChatGPT o1 Pro, or think whatever other LLM you think is amazing. And it has a wealth of knowledge, right? But it also has a cutoff point. It cannot know knowledge past a certain point when it was trained. So, for example, an LLM that was trained 6 months ago cannot know, events that transpired in the past week. It cannot know documentation of software that was written in the past week. It cannot know the price of the SP 500 yesterday. It cannot know, the weather today. It cannot know a bunch of stuff because it's past its cutoff point, and that's just the way it is. There's also the aspect of like, even if the knowledge happened before its cutoff point, it doesn't mean that the data is within the LLM, because whoever trained the LLM doesn't just ingest every random blog out there. Likely they didn't ingest my blog. So if I want the LLM to kind of know about my content, know my voice, it just doesn't know without me giving it that knowledge. You may also have, for example, proprietary knowledge. So all sorts of companies have internal knowledge bases on how they do internal processes. They may have data sitting in their databases about users or about all sorts of things that happen. And this data is just private, it's proprietary, nobody knows it. Books, documents, all sorts of things. And the LLM doesn't have that. So what if you wanted to have that to help you navigate that data or use it in some sort of way or extract things out of it? This is the core problem that RAG solves. You need specific knowledge within the LLM, whether it's a documentation of a library that just came out, whether it's your blog or your content, so it can kind of write in your own voice, whether it's the price of SP 500 today or the price of Bitcoin or the weather or the traffic, all sorts of data that doesn't have, you want it to have. And that's where RAG comes in, because you could handle this with fine-tuning or even train your own model, but that is just hard and usually not worth it. And I'll get into that in a second. So RAG, which means retrieval augmented generation, it's basically just fancy words for we figure out a smart way to take whatever context we need and put it in the prompt, and the LLM wouldn't have it otherwise, but now it has it because we put it in there. That's what RAG really is. And a few examples I've kind of alluded to already is, if you don't know the weather, you can query an API. Your system, before it passes on the query to the LLM, it can query an API to figure out what the weather is like, and then pass that in with the user query to the LLM so it can generate a good answer. Or a more common way of doing things, if you have like a big body of documents, you can't just feed the entire body of documents into the LLM, because LLMs have limited context. They can only remember so much and they can only reason about so much information. So this is where vectors come in, and I'll make an illustration of kind of how they work. But what vectors are is basically it's a way to map concepts, words, phrases, or even paragraphs, but concepts primarily, into a mathematical coordinate. And that basically allows you to take multiple concepts, put them in the database, each at their specific coordinates, and it allows you to kind of figure out which concepts are close to one another based on their coordinates. Now, why this is amazing is because as the user's query comes in, you can vectorize that. It's called embedding, basically. You embed that. Now you know its coordinates, and you can look into your database because you've previously embedded all of your body of documents into the database in vectors, and you can figure out, okay, which documents are close to this concept that the user is querying about. And now you have all of this information as kind of displayed here, and the LLM can reason about the documents that it was given through this process. This is what most of RAG is. It's about documents, and it can help you basically, find information within a large knowledge base. It can help like a chat support move faster, either by augmenting the human chat support or by creating a chatbot. It can help you do extraction of important data within a large body of documents. Maybe you have to review like very, very large documents and you're just trying to find key points, your key insights within that body of documents. Many, many things like that you could do. It can be, and one way I love to use it as a developer is to have it basically find information that I need within a library, within the documentation of a library that I'm integrating. That's the core thing. As I said, I'll add an illustration of a vector and how it kind of maps things out to coordinates and whatnot. But that's the core thing you're gonna do. Now, there are caveats, there are nuances, there are things that are hard about this. You can't really just dump, for example, documents within the vector database, because you could have a large document that may talk about multiple concepts. And so what we sometimes do is chunking, which basically means we take the document and we separate it in multiple parts, each with its own concept, and then we store those within the vector database. Another important thing to kind of note is that the user might ask multiple questions within the same query, and so you also want to have the LLM analyze the query before and figure out, okay, are there multiple concepts here that we could search for? Are there multiple questions here that we could handle? And then potentially handle those in parallel to improve the quality of the response of your chatbot. These are all things like chunking. These are all things that you have to take into account, and you have to really, really do well if you want your RAG chatbot to also do well. You can't just slap information into it haphazardly, but ultimately it's really not that insanely hard as the fancy people out there on Twitter might lead you to believe. It's really just, hey, figure out how to vectorize this body of knowledge so that it's easy to search and find whatever you need within it, and then just feed it into the LLM on demand based on the user query. That's the gist of it, right? That's RAG TLDR.